on green vehicle technology, which is very relevant in the present scenario. We know overexploitation of nature has disrupted its own ecological balance. So it's time to find some alternative that can reduce pollution. Today, we have a very proficient speaker in the topic electrical vehicle technology, Mr. Ahammed bin Zacharia. He is a senior certified CAD engineer from CAD Center Calicut. He is well versed in electrical vehicle technology. He is also good enough in 3D printing, SolidWorks, Autodesk, Rivet, MEP, Advanced Excel, etc. So I convey our wholehearted welcome to Ahammed bin Zacharia, sir. So over to you, sir.
Thank you, Vincent. So I'll share my screen.
Yes, sir, you can.
Okay. Okay, great. I hope the screen is visible to everyone.
Yes, sir. Yeah.
Thank you. So once again, welcome to our webinar. As you all may know, the webinar topic is green vehicle technology, electric vehicles and their future. Okay. Conveniently, today is the Environmental Day, and your college, the VVIT Institute, has selected a very good day to conduct a very good seminar. So first of all, I convey my best regards on behalf of myself and CAD Center for giving us this opportunity to share the idea and concept and the thought process of EV and the future with future students and future EV engineers. Thank you, sir. Thank you for your efforts. So first of all, let me introduce myself. My name is Ahammed bin Zacharia, as you may all know. I am a mechanical engineer working as senior mechanical CAD engineer at CAD Center, working in railway station Link Road, Calicut. So we have been conducting EV courses and EV seminars for some past 1.5 years because it has been popular in Kerala, and the concept of EV has been getting widespread and it has been growing for a small period of time in our areas. So I'm not elongating my brief introduction. Let me go to our agenda for today's webinar. So the agenda for today's webinar is as follows. First of all, we'll discuss about the introduction or the basic concepts and classifications of EV. Then we will talk a little bit about the history of electric vehicles, because for studying anything, we need to go back. We need to travel back in time and get the basic ideas about the history and sort of things like that. Then we'll get to know about the key players in the market of EV. Then we will say about the Indian industry and EV in the industry. Then we'll discuss the future scopes and challenges. And last, we'll conclude by discussing about CAD Center's role in EV technology training. So once again, I'm reminding you that, reminding all the participants to kindly mute yourselves because it will be a little bit disturbance to other participants. Maybe some noise will be coming. And I request others to off your video also, because the video streaming will also affect the quality of my presentation. So maybe along my presentation, I will off my audio, my video also. If any problem arises, please raise your hand. Then our co-host, Mr. Vibin sir, will clarify your problem or sort of the technical issues. So let's begin. So welcome one and all. Let's begin with what is EV. As we all know, EV is the short form for electric vehicles. We all are well versed with IC engines and conventional IC engines and conventional engine vehicles. So നമുക്ക് എല്ലാവർക്കും അറിയാം, ഇപ്പൊ കറന്റ് നമ്മുടെ മാർക്കറ്റിലും നമ്മുടെ സൊസൈറ്റിയിലും നമ്മുടെ ചുറ്റുമുള്ളതെല്ലാം IC engines എന്ന് പറയുന്ന internal combustion engines ആണ്. Okay, maybe some of you are not well versed with that term, but I believe almost all of you will be familiar with that term. Internal combustion engines എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ they will have some sort of burning mechanism, combustion mechanism to burn the fuel, which will be mostly diesel or petrol. And by burning this fuel, we will get the power or energy to run the vehicle. അങ്ങനെയാണ് സാധാരണ നമ്മുടെ IC എഞ്ചിൻസിനകത്ത് IC എഞ്ചിൻ വാഹനങ്ങൾക്കകത്ത് എനർജി ക്രിയേഷൻ സംഭവിക്കുന്നത്. അങ്ങനെയാണ് നമുക്ക് ചക്രത്തിലോ നമ്മൾ എപ്പോഴും പറയാ എങ്ങനെയാണ് ബേസിക്കലി മോഷൻ കിട്ടുന്നത്. സോ നമ്മുടെ വീലിലോട്ട് എനർജി കിട്ടുക, മോഷൻ തരാനുള്ള എനർജി കിട്ടുക നമ്മുടെ ബേണിംഗ് ഓഫ് ദ ഫ്യൂവൽ എന്നുള്ള ഒരു കൺസെപ്റ്റ് വഴിയാണ്. ബട്ട് ഇലക്ട്രിക് വെഹിക്കിൾസ് എന്നുള്ളതിനകത്ത് നമുക്ക് ആ ഒരു ബേണിംഗ് ഓഫ് ഫ്യൂവൽസ് എന്നുള്ള കൺസെപ്റ്റിന് യാതൊരുവിധ പ്രസക്തിയുമില്ല. ഓക്കെ, ഹിയർ വി ഹാവ് എ ബാറ്ററി. ബാറ്ററിനകത്ത് ഇലക്ട്രിസിറ്റി സ്റ്റോർ ചെയ്ത് വെച്ചിട്ട് ഒരു ഇലക്ട്രിക് മോട്ടോർ യൂസ് ചെയ്തിട്ടാണ് നമ്മൾ വീലിനെ കറക്കി നമ്മുടെ വാഹനത്തിന് ഓടാനുള്ള പവർ ഉണ്ടാക്കി കൊടുക്കുന്നത്. ഇതാണ് ബേസിക്കലി നമ്മൾ ഒരു EVയെ കുറിച്ചും ഒരു IC എഞ്ചിനെ കുറിച്ചും പറയുമ്പോൾ ആദ്യമായിട്ട് മനസ്സിലാക്കേണ്ട കൺസെപ്റ്റ്. സോ നമുക്ക് എപ്പോഴും നമ്മൾ ഏതൊരു കൺസെപ്റ്റ് പഠിക്കാന്നുണ്ടെങ്കിലും നമ്മൾ എന്താ അറിയണം, അതിന്റെ കോമ്പറ്റീറ്ററെ കുറിച്ച് അല്ലെങ്കിൽ അതിന്റെ സിമിലർ കൺസെപ്റ്റ്സിനെ കുറിച്ച് അറിഞ്ഞിരിക്കണം. സോ ഞാൻ വീണ്ടും പോകുന്നത് IC എഞ്ചിൻസും ആയിട്ടുള്ള ഇലക്ട്രിക് വെഹിക്കിൾസിന്റെ സാമ്യം അല്ലെങ്കിൽ ഡിഫറൻസസ് കമ്പയർ ചെയ്തിട്ടാണ്. സോ okay, some are saying that they can hear the audio. Okay, I hope our host will sort out the issues. So let's.
So audible, sir.
Okay.
You can continue.
Okay, thank you. So let's go along with our topic. It's about IC engines vehicles versus electric vehicles. So ICE stands for, as I said earlier, it stands for internal combustion engines. Okay, internal combustion engine vehicles and electric vehicles. The first difference, okay, the first difference will be, excuse me, just a second. We will have an engine in our IC engines, and secondly, in a common conventional vehicle, we have the clutch. Okay, to change the gears and sort of things like that. Then we will have the transmission mechanism, which will include the flywheel and the connection with the clutch and things like that. Then we will have the differential to connect or to transmit the linear power along with our two wheels on the rear side. Okay, so this is the powertrain of IC engine vehicles. Should note that this is the powertrain for IC engine vehicles. We have an engine, clutch, transmission device, and a differential. When compared to this, in an electric vehicle, we will only have a battery pack. We do not need an engine. We will have a battery pack. Then we will have an inverter to convert the DC current stored in the battery pack to convert the DC power source into either AC or DC. We have both sort of working because we will need a motor or generator to convert that electrical energy into mechanical energy, and by that to rotate our wheels and get the working going. Okay, then we will have the differentials as always to convert that linear energy into our wheels. Okay, as you have, some of you may have noticed that in our electric vehicle powertrain, we have a dotted line when connecting battery pack, inverter, and a motor generator. This is because we can say that most of these components, let's say 2/3, that is battery pack and inverter, can be taken as a single component. Okay, when compared to our IC engine vehicle, I'm trying to convey the idea of less number of parts in electric vehicle when compared to IC engine vehicles. So in an IC engine vehicle, we have an engine, clutch, and transmission, while in our electric vehicle, we have a battery pack, inverter combined into one, and we have as must motor or generator. Okay, when we are comparing other differences between IC engines and electric vehicles, we can see that there are very less number of moving parts in an electric vehicle. Okay, this term is very important when stating efficiencies, okay, and lifespan. Okay, the important two terms are efficiency and lifespan. Okay, when we have large number of moving components, the efficiency and lifespan tends to reduce by a large factor. Okay, in an electric vehicle, we only have a static battery pack. It doesn't move at all, and we also have an inverter. This also doesn't move. The only moving components are from the motor onwards. We have a rotating motor mechanism. We'll also have a differential mechanism. Let's say we only have two moving parts in our EV. Okay, I'm simplifying this to a very large factor. I'm simplifying this to a very large factor to convey my idea to everyone in our webinar. But when we are comparing with our IC engine vehicles, when we are going to our IC engine vehicles, we have an engine. As we all know that engines combust some fuel. Okay, engines burn some fuel. When burning, we know that the pistons move, pistons rotate, or pistons stroke against each other. Okay, we have moving mechanisms starting from the engine itself. Then we have large number of moving mechanisms again. We have the clutch, we have the transmission device, we have the flywheel. There are a large number of moving parts, and so the efficiency and the lifespan of IC engine vehicle will be very less when compared to electric vehicle. So this is the basic concept that you all should be aware when we are going to study more about electric vehicles. So I hope this is clear to everyone. Let's continue with our topic. As you may all see, there is a slide in front of you showing a very interesting picture of smart vehicle concept. Okay, this concept is very relevant in these days. Okay, also in these days of corona hit times. Okay, as you may see, there are many terms in here. There is a term of visual mechanic, accident detection, stolen vehicle tracking. Please follow through all these terms. In all these terms, you are seeing the added features that are getting implemented in the current new vehicles and also in the future upcoming vehicles. Okay, as we all know, in the older automobiles, there were no digital meters, digital speedometers or digital fuel indicators. But nowadays, all including our scooters and motorcycles, there is a digital speedometer and a digital fuel meter is there, or fuel indicator is there. So everything is taking a digital transition nowadays. Okay, this digital transition or this transition trend is only going upwards. It is not at all coming down. So in a smart vehicle, to function all these terms, to function all these umbrella terms, we need large electrical power. Okay, but in a conventional IC engine vehicle, we cannot provide that electrical power using our combustion mechanism. In every, you may know that in every automobile currently in our roads, there is battery packs inside. I'm not speaking about electric vehicles, I'm speaking about IC engine vehicles. In every IC engine vehicle, there is a battery pack and electricity providing mechanism in every vehicle. Why is that so? Because we need many important functioning things like lights. We also need like our digital speedometers. We need sensors to measure the tire pressure, the air capacity in the tires, maybe the airbag mechanism, the display mechanism. Everything needs power, electric power. So in every IC engine, there is battery. But let's think like that. If we are getting the power to run our vehicle, okay, our vehicle from the single source, from a single battery source, and using that single battery source, we are connecting all these smart components, then we can say that we only need few components. Okay, otherwise in an IC engine vehicle, we need a combustion mechanism or engine mechanism to run the vehicle, and we need a battery mechanism to operate all these other smart entities. But in an electric vehicle, we will only have a single source of power, and using that, all these smart components and also the running work of the vehicle will be satisfied. So slowly we are getting into the idea of electric vehicles. So next we are going to discuss about different types of electric vehicles. Maybe this is a little bit fast for okay, excuse me. Okay, I hope my audio is clear. Some are saying that it's a little bit problematic. Okay, anyway, let me continue. There are mainly 4 types of EV in the industry. Okay, they are, as in the screen, they are battery electric vehicle. This is the purest type of electric vehicle. Okay, because there is no IC engine component in the battery electric vehicle. This is the first type of electric vehicle. Then we have hybrid electric vehicles. Hybrid means, we all know, hybrid means it will be a mixture of 2 or more mechanisms. When talking about electric vehicles, it will be a combination of conventional IC engines and also the battery mechanism. Then we also have plugged in hybrid electric vehicle. Okay, this is also another type of hybrid electric vehicle. We'll talk about that soon. Then we have the last and the most promising type of EV, that is fuel cell electric vehicle. Okay, this is entirely a new, not a new concept, but it is not so popular and it is not so common in the market. It is only in the research and development field, but let's hope that it will be coming soon. And when it comes, it will be a great game changer in the EV industry. So first of all, let's go discuss about battery electric vehicle. In the battery electric vehicle, only the battery pack is the power source. So that's why it's known as a battery electric vehicle. A common and a popular example, real life example for a battery electric vehicle is that Tesla Model S. You all may be familiar with the term Tesla. It is the American startup begun by Mr. Elon Musk. His name is currently very relevant because recently, last week only, the SpaceX company and NASA, okay, the space organization of USA, collaboratively sent 2 astronauts into the space station, into the International Space Station. Okay, it was a very successful work and it was so popular. I followed it live in YouTube and everything. Maybe some of you may have heard about that. So Mr. Elon Musk started a new company, that was Tesla. It was an electric vehicle company and it is currently the most popular electric vehicle choice for almost a large number of people in the world. So for battery electric vehicles, Tesla Model S is the best example. Okay, the next type of EV, the next type of EV is plug-in hybrid vehicle, or this is also known as a series hybrid electric vehicle. This hybrid electric vehicle has 2 power sources. First will be the IC engine. The primary source will be the IC engine, and the electrical driveline or the electrical power source will only be the secondary source. So when the fuel is going to run out, okay, or when the user needs more torque or more speed, the car will automatically switch to electrical driveline, or we can shift the gear and go to electrical driveline. The famous company, Toyota, automobile company, Toyota has many cars that are currently plug-in hybrid vehicles. One of the examples as shown in the screen is Toyota Prius, which is a common plug-in hybrid electric vehicle. The second type of hybrid electric vehicle is plug-in hybrid electric vehicle or parallel hybrid electric vehicle. Okay, this is the second type of hybrid electric vehicle, and in this, the primary source is electrical driveline. Okay, in the first one, the primary source was internal combustion engine, and only the secondary source or backup source was electrical energy. But in here, the primary source itself is the electrical energy. So in this situation, when the battery is going to run out, only then the fuel will be consumed. And also we know that, some of you may know that, when we are ascending a steep slope like a big hill or something like that, the electrical power will face some difficulties. During these situations also, the IC engine can support our vehicle and we can get the better result. So this is the third type of electric vehicle, that is plug-in hybrid electric vehicle. The last type is, as I said earlier, is our fuel cell electric vehicle. So in this, the power source is a fuel cell. Okay, and a fuel cell gets energy by chemical reaction. And the best thing about chemical reaction in a fuel cell is that the output is water, because we are going to combine hydrogen and oxygen, and the end result of combining hydrogen or the oxygen will be H2O, and we know that we can get pure water molecule in a fuel cell. So the research and development in fuel cell electric vehicles is most popular in the space industry, because as we all know, currently the space race is on. The space race is on between government organizations and also private organizations. As I said earlier, SpaceX is a startup by Elon Musk, and it has collaborated with NASA already, and it is trying to collaborate with Russian agency, and our ISRO is also a big runner in the space game. So in the space game, we know that we can only take a limited volume of load to the outer space. Okay, so when a large number of people, and when we are going to think about colonizing Mars and colonizing Moon, okay, we need to think of creating water at that space. Okay, so fuel cell electric vehicles are a good example. Currently, there are some fuel cell electric vehicles which are sort of prototypes, not so customer products, sort of prototypes. They are fuel cell electric vehicles are currently running in the roads, but they are mainly prototypes only. Not much customer products are there in the market. One of the best examples is Toyota Mirai. It is a fuel cell electric vehicle. It's a very popular fuel cell electric vehicle in between in the EV industry and EV enthusiasts. So these are the four type of electric vehicles, four important classifications electric vehicles. So I hope that the basic concept of EV is clear for all of you. We can say that in an electric vehicle, the power source is an electric battery which provides the electricity. Okay, we have very less number of moving parts. We have basically less number of parts also, and the output. Okay, as we all know, there is no output at all, no pollution at all, no contamination of the environment at all. So the damage that we are creating by IC engines can be negated using the electric vehicles. Okay, so this is the basic concept of EV. So let's go to the history of EVs. So for most of you, EV will be a new concept. Okay, maybe you have heard about EV for the last year, maybe last 3 or 4 years, but we should know that EVs or electric vehicles were there long before even the conventional IC engine vehicles. So during the 1830s, I believe it was in 1834, the first working electric vehicle was created. Okay, long before the first IC engine vehicle. That is a fun fact. So some of you may be wondering why the hell is electric vehicle not so popular currently in our world itself, not in India, but throughout the world only IC engine vehicles are currently popular. The answer we are going to see soon. So in 1830s, 1834, I believe, the first electric vehicle was invented. Then in 1886 only, the first IC engine vehicle was created, and this is the first IC engine car, as you may see on the right side. And in 1897, large electric taxi fleets, okay, electric taxi fleets, I mean the large number of electric taxis were popular in the cities of London and Paris. You may search in the net. In 1897, the large number of taxis were popular in London and Paris because they were the most modern cities at that time. Now also they are the most modern cities. So in 1899, the car you see on the right side here, it was the first car to go faster than 100 km/h. Nowadays 100 km/h is not a big thing for us because almost all vehicles have speeds which are greater than very greater than 100 km/h. But on that times, in the 1900s, 1899, to go faster than 100 km/h was a big deal. And the first vehicle that could go faster than 100 km/h was an electric vehicle. Okay, it was created in the Europe. I don't know exactly. I don't remember exactly in France or Italy. It was known as La Contente. La Contente means never satisfied. Okay, I think the man behind the invention was a very enthusiastic, very crazy racer. So he was never satisfied with the IC engines. So he went for the alternate, the electric vehicles, which was a good choice for him. So in the 1908, okay, the Model T came out. Okay, this is the Model T, and this face may be familiar to some of you. What is the importance of Model T? Model T is not an electric vehicle. For the information of most of you, Model T is not an electric vehicle. Model T was the first mass manufactured IC engine vehicle, manufactured by Mr. Henry Ford. Okay, Mr. Henry Ford manufactured the Model T for a meager $650. Okay, at that time, the cost of electric vehicles were around $2,500. So you can see the difference. Okay, $650 for an IC engine and $2,400 for an IC engine. Sorry, the electric vehicle. So most of the people went to IC engines, converted to IC engines. And large number of fueling stations, let's say the petrol pumps or diesel pumps, popped up in America. Then the large number of people or consumers started using the Model T and other IC engine vehicles, and there were some disadvantages with the electric vehicles currently in that time. So the decline of electric vehicles began. From that term onwards, steep declining or steep downward growth was in the EV industry. But the growth began in 1974. Some of you may have seen this red mini model. It was the city car. Okay, it was very popular in India also. In the Bangalore and Delhi, I heard some seniors saying about city car in the cities of Bangalore and Delhi. So the city car, it was a very compact, very non-polluting, less costly, very economical vehicle. So it became getting popular with the common people, and thus became the growth again of electric vehicles. Then in 1990 came the ZEV mandate. ZEV mandate means zero emission vehicle mandate. Okay, globally or basically in the North America and then globally, there was a concern for the environment, and so for the concern for the climate change, the environment, and people started getting concerned about the pollution of the IC engines, and so the zero emission vehicle mandate or rule was introduced, and many companies like Ford and other companies started creating electric vehicles. In the 1996, General Motors, a very big player in the automobile industry, created their very first electric vehicle known as EV1, and it was a very popular choice in the America. And from there onwards, very large number of companies began creating electrical vehicles. And in 2006, something came up that changed everything, and the sudden upward growth of EV began. Okay, it was the introduction of this vehicle that you are seeing in the screen. Some of you may have recognized this vehicle. It is the Tesla prototype model. Okay, 2016 was the year when Mr. Elon Musk began his company Tesla, electric vehicle company Tesla, and from that year onwards, the growth of electric vehicle was very fast. Let's say very fast and very disruptive, in fact. Okay, from that onwards, very large number of electric vehicles. That was not very local electric vehicles like city car or EV1, but very popular, very economical, very efficient electric vehicles like the Mitsubishi Egg in 2019. It was very popular in Japan and China, where road space and traffic jam was big issues. And in 2010, Tesla Model S sedan, it was a luxury model, and also Nissan Leaf. It is the most sold electric vehicle currently in the world. Okay, most common sold vehicle in the EV industry. So from that day onwards, large number of companies began creating EV, like the Chevrolet Volt. It was a startup, let's say acquired by Chevrolet. It was a startup known as Volt. It was later acquired by Chevrolet, the popular automobile company. Then Tesla created another model, Tesla Model 3, the red one you are seeing in the screen. It was a big hit with the market. And then again Chevrolet came out with a big EV. Then Volkswagen also began creating EVs. Then in the Asian space, okay, in China, mass manufacturing of EV began, and by mass manufacturing, as you all know, cost gets reduced, and EVs began getting more popularity. So this is the brief history about EV. So after only knowing that EVs were created long ago before IC engines, we can study about the future of EV and the current situation of EV. So as promised in the agenda, let's go to the Indian automobile industry. So Indian automobile industry is the 7th largest manufacturer of commercial vehicles in the world. Okay, it is the 7th largest manufacturer. It has created 30.92 million vehicles last year, in the year 2019, and it expects to reach the income, the GDP from automobile industry expects to reach a whopping 16 trillion Indian rupees in the year 2026. But, okay, there is always a but. So these expectations were upturned by what? As you all know, by the COVID crisis. Okay. So by COVID crisis, what happened? The industry, every industry was hit. Along with that, the automobile industry was also hit. As you may see on the right side, the loss was very big. Okay, the current loss is 17%, and it is speculated that it may hit very big loss of 30% or more. Okay, as you may see in the right side, if we are not getting a sale of 76 million, okay, that this 76 million cars is the amount of cars that were sold last year, last financial year. Okay, if we are not getting 76 million number of cars sold, then it is a loss. Okay, if we are only getting 63 million number of cars sold, then it is a 17% loss, and if it is only 54 million cars, then it is a 30% loss. Okay, but the speculation is the loss is going to be much worse than that. Okay, because only the lockdown is getting taken away right now in India. Okay, also in some hotspots and some critical regions, the lockdown is still in fact. In the other countries, in America, it is very dangerous situation currently. Then in China, it has been, let's say, they have overcome, and in other countries also they are coming up with measures to overcome the crisis. So if we are not able to overcome this COVID crisis, the sales will surely plummet. Okay, but always for every cloud there is a silver lining. For every cloud there is a silver lining, and we will surely overcome this crisis. Okay, let's hope that we will all overcome this crisis. Currently, let's take a small minute for two things. Okay, for two things. Let's take a minute for two things basically. First of all, to pray for all of us. Okay, to keep safe, to be happy, be healthy, and be safe in this time, this critical time of COVID-19. And second, for the environment, because the environment has been uplifted due to this COVID situation and the lockdown and the quarantine. Us human beings polluting and damaging the earth has been reduced by a large factor. So the environment is greatly profiting from the lockdown. Okay, but we should also be considering the fact that most of us are being financially hit, and we need to overcome this situation. So we will surely overcome this situation, and the automobile industry and the EV industry will also overcome this situation. And there are some measures taken in some measures or some ideas that are being implemented in the automobile industry that I'm going to share with you next. So the government, the Indian government, before the COVID crisis and now also, they are aiming to develop India as a global manufacturing center and a research and development hub. Okay, for the whole world. By that, we will be, we all know that Make in India was a very popular or a very uplifting measure taken by the Indian government. So like that, to enhance the automobile industry also, along with the Make in India concept, the Indian government is aiming to develop India as a common platform for large vehicle manufacturers to come steady, manufacture and research the new concepts and the existing concepts, and make India more great again. And there is another idea to create R&D centers. The total cost of, as you can see in the screen, $388 million US. Okay, we are speaking in the global standards now. With the total cost of $388 million US to keep India be with the global standards. We all know that India is always as a developing country. But we are always aspiring to be with the main players, with the developed countries. So to keep India in the race, to keep the Indian automobile industry in the race, the Indian government has proposed these methods or these ideas to, as I said, to uplift the automobile industry. So next, let's see some popular or most common or most prominent EV manufacturers in the Indian market. First one is Hero Electric Vehicles. Hero Electric Vehicles are very common with their four-wheelers and also their two-wheelers. An image here shown is the Photon Hero Electric scooter, which was a very popular scooter model. Then we have the Tata Motors. They are coming up with many ideas. Tata being a very global player, okay, very global player. So they are a big contender in the race for EV dominance. So the next one is MG Motors. MG is not an Indian by origin, but it is a big player in the Indian market. It is Morris Garage's Motors. So a very common EV model for MG is the Hector. It is the first model, I believe, which has IoT connection, Internet of Things connection, which is connected to the internet, and large things can be done with the Hector model. Then the other one is Mahindra Electric. Here the model shown is Mahindra Trio, TREO. It is an auto rickshaw which is very popular. Also, some of you may have seen in Kerala itself, in our district of Calicut itself, the model Trio. It is a very popular EV auto rickshaw. Then we have the Hyundai Kona models. In Hyundai Kona, K-O-N-A Kona models are also very common, very popular models in the Indian EV industry. Then we also have the most family-friendly model, that was Wagon R. Wagon R is getting converted into an electric vehicle, and later on, let's expect soon. Okay, it has not been in the market, but it has been teased by the Maruti Suzuki companies. It will be soon in the market. The electric vehicle, Wagon R electric vehicle, will be soon in the market. So these are not the only players, okay? These are not the only players, but these are the most prominent players. And there are many other players like Leather, Ashok Leyland, and there are many EV manufacturers and EV distributors, but these are the most prominent and most important players in the EV industry of India. So next, I'm stating something in front of you. So you all think about that. I'm concluding that future of EV in India is bright. I'm not concluding my session. I'm concluding a comment. I'm stating a comment that future of EV is very bright in India. Why is that so? So I'm giving you 3 reasons that I believe are the most important 3 reasons to support or to defend my statement of my statement about bright future for electric vehicle. The first defense I say is that the BS6 and the eco-friendly mindset. What is BS6? Some of you may know that BS6 is the Bharat Stage 6. Okay, the Bharat Stage is the the stages set by Indian government. Okay, they are the measures to rate the to rate the automobiles that are coming in the market, coming in the Indian market. Okay, there have been Bharat Stage 3, Bharat Stage 4, Bharat Stage 5, and currently the Bharat Stage is 6. Okay, in the Bharat Stage 6, the environmental impact of the IC engines need to be negated. Okay, in the Bharat Stage 5 itself, the environmental impact is to be reduced by a very big factor. Okay, so the coming of Bharat Stage is the Bharat Stage 6, and by the Bharat Stage 6, large number of automobile manufacturers need to slowly shift into the EV field. Okay, because the Bharat Stage 6 will talk with reducing the air pollution by a large AQI. Large AQI means air quality index. Okay, when the AQI is very less, it means there is a big pollution rate in that city or in that country. Okay, so and also we human beings and we Indian citizens are being concerned a lot about the environment. Okay, we are almost all are going to shift to the green environment concept or eco-friendly mindset. So we all are concerned about the environment. We all know that to sustain ourselves or maybe our future generations, we need to try living in a sustainable manner right now without harming our planet very much. Okay, for our sustenance, we need to harm the planet a little bit. Minimum there is a rate, but there is no maximum limit. Maybe we can destroy the planet by our oversightedness or our selfish nature. But let's say human beings are overcoming our bad nature, and we all are coming together for the green environment movement. And so this is my first supporting statement. And the second supporting statement is that Indian government itself is trying to reduce oil imports. Okay, because India is a big oil importer, okay, from America and from other countries, from Iran, from Saudi Arabia, many oil exporters. You can see in the screen what is the volume of the petroleum industry or the import industry in India. So when we are switching to electric vehicles, by switching to electric vehicles, we can reduce this major GDP expense, okay, of oil importing, and we can use that amount for the betterment of our whole society. So this is the second statement that I'm putting in front of you. The third statement is incentives. Okay, for everything to be popular or for everything to grow, there should be cost incentives or financial incentives to the common people. As we saw in the history slide, okay, you saw that when Ford Model T was introduced for a meager $650, okay, the $2,400 electric vehicle model got away. Okay, it got unpopularized and the cheaper Ford model was more popular. Why was it so? Because it was less costly, it had less expenses and more people could buy it. So this is the first thing. The EV manufacturers, they cannot reduce their cost very much because they have their own expenses, their own manufacturing expenses are there, their own R&D expenses are there. But the government can provide GST reductions, tax exemptions and other incentives for new electric vehicle buyers. Okay, for this incentive concept, we can take examples and ideas from other foreign countries also. One of the biggest player in EV industry or EV market is Sweden. Okay, Sweden is a very modern country, very developed country. In Sweden, we can see a large number of electric vehicles. I'm not saying that I haven't gone to Sweden. I'm saying from experience and from knowledge that in Sweden there are a large number of electric vehicles, much more than in America. Okay, there are large number of Tesla models in Sweden than in America. The main reason is that the Swedish government is providing tax exemptions, and let's say we have our toll plazas and toll booths, okay, in the highways and in the new bridges. Okay, for electric vehicles in Sweden, there are no toll fee. Okay, for them, there are no toll fee for the electric vehicle consumers and the electric vehicle users, and they are providing large number of free charging stations in the public roads in Sweden, and by that they are attracting more and more new buyers, and by that they are helping heal the planet. Okay, and they are helping save their country itself. Okay, to give a better living for the future Swedish citizens maybe. So we can take models and take ideas from such examples, and the government already has started giving incentives for the new buyers. So these are the three statements that I'm giving to support my comment about the future of EV in India. So again, I'm stating that the future of EV is very bright in India. These are the three statements, and I can give you many more statements. If anyone have any disagreement with you, I'm open for discussions. Later on, we can discuss about that. So next, I'm providing in front of you some startups, some EV related startups. On the right side, in the top right, you can see some battery manufacturers. Okay, first I'm saying about battery manufacturers because battery is one of the most important entity in an electric vehicle. Without a good battery, there is no good electric vehicle. Okay, the Tesla company are investing a large amount on their battery research rather than on their automobile research. Okay, so battery manufacturers are very important, and these are the most important players in the most important startup players in the battery manufacturing industry. Then we have the four-wheelers. Then we have the two-wheelers on the top left side, and we have the charging stations on the bottom left. Charging stations are also a very important concept when we are speaking about electric vehicles, because electric vehicle charging station is not at all popular currently in India and also in the global market. Okay, we have large number of petrol pumps in our country, in our state, but have most of you seen any electric charging stations in Kerala? Have you seen any electric charging station in Calicut? Yes, there is charging stations in Calicut. I have seen charging stations in Calicut. I have worked in the charging stations in Calicut. In Palayam, we have a charging station, but charging stations are not so common. So the government needs to come up with more charging stations, and they need to support the startups. They are creating the charging stations. So these are some of the startups in the EV industry. Then I'm showing you some EV companies. Tata is a very popular EV company. Then we have Atul. Atul is an old company. It is getting converted into the electrical industry. So these are some of the logos of the electric vehicle manufacturing companies and electric vehicle players, as I said earlier. Then showing you some newspaper clippings. The first one is that the article about the EV industry, which is going to create job opportunities, 10 million job opportunities in the future. Because as I said earlier, as I stated to earlier, as I tried to convey to you earlier, the market is turning around. Okay, it's turning upside down. The IC engines are giving way for the electric vehicles. So some jobs are going to go away and some new jobs are coming up. We'll talk about that soon again. So there are some newspaper clippings about the EV industry going to create some new emerging job roles. Then the job roles for an electrical vehicle engineer, okay, are as given below, and there are more job roles currently. Okay, as you may know that if you studied BTech electrical engineering or BTech mechanical engineering, you are not directly going to work as, or you are not only going to work as a mechanical engineer or an electrical engineer. Your job role may be a little bit different, maybe technical electrical engineer or junior electrical engineer, maybe like that. Some designations will be given you for you. So like that, there are a large number of roles or designations currently for electrical vehicle engineers. I'm showing you this because electrical vehicle industry or electrical vehicle market is a collaboration between electrical engineers, automobile engineers, mechanical engineers, information and technology engineers, computer science engineers, and large number of things like that. Chemical engineers, I forgot that, very important player in the electrical vehicle industry, chemical engineers also. Why is that so? Because we are talking about an automobile. So there is importance for automobile engineers. We are talking about power mechanisms and the wheel motion, differential and things like that. So we need a mechanical engineer. But we are talking about electricity and battery. We need electrical engineers, very important. Then we did chemical engineers. We need chemical engineers for the battery mechanism and this like that. Then we have the sensors, pressure detectors, and the displays, things like that. So we need computer science engineers and information and technology engineers. So EV is a large collaboration. So if you are an electrical engineer without any knowledge about automobile industry, without any knowledge about computer science engineering, without any knowledge about chemical engineering, you are not going to succeed in the EV field. As such, if you are a mechanical engineer with no knowledge or with no respect for these other disciplines, you are not going to succeed. If you are a chemical engineer with no respect for the other disciplines, you are not going to succeed. So you should be a core engineer in some field, core engineer, core electrical engineer, or a core mechanical engineer with knowledge in these other important terms. Okay, so your job designations may be a mechanical engineer in the EV industry, battery parts engineer, maybe an electronic engineer, electronics hardware engineer. You may be a lead engineer in the test and validation field. You may be a battery systems engineer. So these are the some job roles currently available for electrical vehicle engineers. So we have said about basic concepts of EV. We said about the history. We said about Indian industry. We said about the startups in the beginning roles for EV engineers. So we are going to our final session. We're going to discuss about the challenges or disadvantages of EV, or the challenges in adopting electric vehicle. Maybe some of you are familiar with some disadvantages. The first and most common disadvantage is the limitation of available charging stations. Okay, I have shown here one of the first charging stations that was in Kerala, in Tirunelveli, I believe it was. I think it is in Tirunelveli. I strongly believe it is in Tirunelveli by the government itself, by KSEB itself. As you can see, there is a single charging point. Okay, it's only a single charging point, and there are only a few like these. But currently in Calicut also there are I think 3 currently in my memory. There are 3 private charging stations, and some are also coming up. Okay, so charging station limitation is the first important disadvantage. The second one is the drive range for a single charge. Okay, drive range means we say about it as mileage. Okay, we say that for a vehicle we have 80 kilometers mileage. It means that for a full charge, for a liter, we can travel 80 kilometers per hour. Sorry, 80 kilometers for a liter. Okay, so we are not talking about a liter. We are talking about the maximum capacity or a full charge. Okay, when an automobile or a 4-wheeler is fully filled, okay, it can travel more than 500, 600, or even 800 kilometers. Okay, but for EVs, currently the range is very less. For a fully charged Tesla Roadster, it is only 200 miles. That is near to 400 kilometers. Okay, this is the leader in the EV industry. Then we have General Motors EV1. It is only 140 miles, or let's say 280 kilometers. So this is the second limitation, that is the drive range for a single charge is very less currently. Okay, the second one is charging time. The charging time is very high currently. Okay, because of not available of the appropriate charging stations. Okay, if there are appropriate DC charging stations or AC charging stations, then the charging time will be reduced by a large number. Okay, in mobile phones also, we know that there are fast chargers, there are rapid chargers, and there are normal chargers. Likewise, in the electric vehicles also, there is normal charging mechanism, there is rapid charging mechanism, there is also fast charging mechanism. Okay, so currently the charging time is very high. Okay, we know in a common vehicle, in a common IC engine automobile, the refueling time is maximum 10 minutes or 7 minutes. But for an electric vehicle, the maximum time will take more than 5 hours, 6 hours maybe in a home. At home charging, it will take more than 6 hours or 7 hours. Okay, but in a high power fast charging public stations, we can speed it up to 7 minutes. Okay, up to 7 minutes we can speed it up currently, but this is also currently a large time. Okay, so charging time is more. This is the third and most important challenge in adopting electrical vehicle. But we are not going to be suppressed by these challenges. We will overcome these. So let's discuss about the remedial measures and actions that are in progress to overcome these challenges. The first one is the implementation and creation of more number of charging stations. The image that I have shown down below is not a charging station in India. It is a public large scale charging station in China. We can take the example of China. It is a very good example, because in China these infrastructures are being popularized and created by the government itself. The Chinese government is creating large number of public large scale charging stations that can accommodate more than 1,000 EVs at a single time. Okay, at a single instance, as you can see in the below image, they can handle more than 1,000 electrical vehicles at a single time. Okay, so this is the first remedial action that we need to take. Okay, that is we should create large number of charging stations, and the government should support that. Okay, the government should support startups and private organizations also. Ola has come up with charging stations in Bangalore. Okay, then Uber also has charging stations. Okay, these are the two taxis, e-taxis, you may know. So these two people have charging stations, like in the image, in metro cities in China, not in Chennai, in Bangalore they have this charging station. And in Calicut we have new startups, new charging station startups like Charge Mode. They have three, I believe 2 charging stations. They have one in Palayam. They are our industrial partner. They are the industrial partner of CADD Center. So we provide our internship for our students at the Charge Mode charging station. So this is the first remedial measure that is to be taken by the government and the private sector. And the second important thing, and the most important thing, is that R&D is very important to improve the battery range. Okay, some of you may know the term, the name Mr. John Goodenough. Okay, I just remembered his name. I didn't think of him while creating this presentation, but just now I remembered his name, Mr. John Goodenough. Some of you may have heard, maybe electrical engineers are familiar with his name, because he is a Nobel laureate. Okay, he's a Nobel laureate in the 2019, I believe. He's a very familiar face in the chemical engineering industry. Okay, he's a very old man, very enthusiastic man in creating and designing new battery technologies. He was a prominent figure in the lithium-ion battery manufacturing and the research and development. So Mr. John Goodenough, currently he is also a prominent player in research and development that is ongoing in the battery range development. Okay, so battery range means in a full charge, we should get large kilometer running. Okay, more than 800 kilometers, more than 100,000 kilometers. Okay, so the Tesla company is coming up with a model. You may search in the net. Please be attentive. Tesla is coming with a model that has 100,000 mile range. Okay, and not wrong, the concept is 100,000 mile Tesla. Okay, the concept is 100,000 mile Tesla. Okay, the American standard is miles, so they are talking like that. So let's, when converting to kilometer, it is little bit more than 2 kilometers. 1 mile is little bit more than 2 kilometers. So let's say 200,000 kilometers for a single charge. So the new concept is buying a new EV, then using it for our whole life. Then we have a, when we have a child, or when we are going to sell our electric vehicle, we will sell it away, or we will give it to our child. Okay, this is the new funny meme in the EV industry, when Tesla came up with the idea of 100,000 mile battery. So the important action that is going on, and which should be followed up by all electrical vehicle enthusiasts, is that the research and development, the battery is very important. So these are the two remedial measures and actions in progress that are to be followed. So next, we are going to conclude. We are reaching the final slides. So we are going to say about the need for introducing the course on electric vehicles. So there are some electrical engineers in the market, there are some automobile engineers in the market, there are some mechanical engineers in the market. But why there is a need for electrical vehicle engineers and the course on electrical vehicles? The first thing is the shifting trend in the automobile industry. Okay, so all automobile manufacturers are changing from conventional IC engine to electrical vehicles. So as I said earlier, we need the skill of a mechanical engineer, and of an electrical engineer, and of a chemical engineer, and of a computer science engineer. Okay, and also many other things. Okay, all these skills should be under a single umbrella. This is the trend that is coming up in the automobile industry. And the second thing is that many job roles are changing, many jobs are getting lost. Okay, and many jobs are emerging in the automobile industry. Always there is disruptive changes in the market. Okay, unfortunately, engineering students, the syllabus and what we study in engineering colleges, it's not the fault of anyone, but the system, Indian system itself, is a little bit backward. Okay, we the millennials are living in the present. We are studying the topics and the courses of the past, and we are going into the future that is 10 years ahead of us. Okay, when we are going to step out in the market tomorrow, the topics and the ideas there in the market tomorrow will be that of 10 years ahead. But we are not ready for that. We engineers are not ready for that. So there are going to be a large number of emerging job roles. So we shouldn't be stuck in our cocoon of basic electrical engineer. We should not be stuck in the basic cocoon of mechanical engineering or such single disciplines. We should be all loving, like agape. We should be all consuming. We should learn about the most important things that are required for electrical vehicles. So when talking about this changing and emerging job roles, there is a meme, there is a troll that always comes into my mind. A troll of a drone camera shooting from the sky. Okay, think about that. Think about a drone camera shooting from the sky, sky, taking an aerial view. So in the past, to take an aerial shot, we required a helicopter pilot, a cameraman, a safety gear mechanism, a mechanical engineer. All these people have lost their jobs to a single drone. So this is the disruptive change that is happening. Okay, so this is the change and the emerging job roles in the automobile industry. And also similarly, as I said earlier, there are new areas of employment. Entirely new areas are coming up, like autonomous vehicles. Very important term in electric vehicle, autonomous vehicle. Some of you may have heard about autonomous vehicles. Autonomous vehicles are self-driving vehicles. Okay, they do not need a driver. They do not need a human driver. They will drive their own. Okay, so when we have autonomous vehicles, the autonomous vehicles do not need a mechanic, do not need a driver, but it needs a computer science engineer to program it, and an electrical engineer to circuit it. Okay, so entirely new job roles are coming up in the EV industry, that we should be aware of that. So this is the third point for introducing the training on electrical vehicles. And the other thing is varying training requirements. As I said earlier, in a common engineering college or a common field, we are studying about only mechanical engineering or electrical engineering or civil engineering or something like that only. We need to take important things from all of these disciplines. This is the importance of varying training requirements. So this is where CAD Center comes into the screen. Okay, CAD Center, as you may all know, has 30 plus years of experience in the CAD industry, CAD training and CAD services industry. In Calicut railway station, Link Road, we have been working for the past more than 17 years. So we have been teaching many students, many engineering students, engineering working professionals in all engineering fields for the last 17 plus years. I have been working there for more than 2 years right now. I have been promoting their electric vehicle courses, 3D printing courses, and some mechanical engineering courses, mechanical automobile related courses like ANSYS Fluent software, which is very important for computation fluid dynamics, that looks at the aerodynamics of a car, aerodynamics of a vehicle, and aerodynamics of a plane, things like that. So this is about CAD Center, Calicut, and CAD Center overall. So in our center, in the Calicut Center, we have currently launched 2 electric vehicle course modules. The first one is EV Technologies and Operations, and the second one is Battery Technology and Designs. Okay, I'm saying about these courses that are ongoing and launched in the Calicut Center only because there's one thing also, because because the CAD Center office, the CAD Center, our corporate office, has launched a large module, 12 module course on electric vehicle. But as you may see, the later modules are dedicated modules for some specific things. They are, let's say the fourth one is auxiliary systems. Auxiliary systems are the HVAC systems and the AC systems. And the sixth one is the EV maintenance work. And the last one is service center requirement, things like that. So this is the large scale course module launched by CAD Center. The first introductory courses are our 2 modules, that are EV Technology and Operations and the Battery Technology and Design. Because battery is the most important, so we decided to launch the Battery Designing and Battery Operations course right in the CAD Center. So there are ongoing batches in our center, and currently some new batches are also getting launched. Let's for any queries, you can contact our center or your college staff later on. In our course, in the last point I have specified here, in our course we are providing a sure 5-day industry internship with our partners like Charge Mode, and also we have tie-ups with some EV 3-wheeler manufacturers and the charging stations and some other startups also. So we provide a 5-day internship along with our course. So this is about the CAD and our center and electrical vehicle courses. And also this, as I said earlier, this is the full scale course provided by the CAD Center, but you cannot directly jump into all these other modules, because only if you are a working professional in the vehicle AC system, you can take up the auxiliary systems. There is some pre-requirements. Okay, the pre-requirement for our first 2 courses are BTech graduation, okay, or BTech final year ongoing students. Likewise, the pre-requirements for some of these courses are that you should be a graduate or you should be a professional. Okay, so only experts can handle this. Only experts can take in the material that are giving the courses, as you can see in the screen here. So this is about our courses and stuff like that. So I'm concluding my session. I hope that the session has been useful for even a little bit useful for some of you. I have tried to make it useful and try to make it worthy and interesting. I welcome any suggestions, and if there is time, let's have a Q&A session. So on behalf of myself and CAD Center, I once again thank the staff of VVIT for providing this opportunity. I thank all the other participants, all the other students of VVIT and other students for attending my webinar. Thank you. Thank you so much. Handing over to Vivin sir. Thank you, sir.
Thank you, Ahammed sir. The presentation was very nice. It was very informative.
Thank you,
And
sir.
you are a gifted teacher too, sir. Your
Thank you,
presentation
sir.
is very good.
Thank you. You are so gracious.
So participants, if you have any doubt, you can just ask him. You can just unmute your audio and you can just ask any doubts. You have to know anything more. Hello.
Sir, what about the first time period of these courses?
Hello.
Hello, sir. Can you repeat it?
Time period of
Sir, one doubt, sir. What is the difference between fast charging and rapid charging?
Hello, sir.
Difference between fast charging and rapid charging.
Yeah, basically the time difference is the important factor. Okay. And the power mechanism, not the power mechanism, the mechanism of charging the electrical vehicle. Okay, only some are compatible with rapid charging, only some are compatible with fast charging. Okay, this is the difference. Okay, let's say one is fast and one is very fast charging. Okay, to be frank.
Okay, so another thing is, most of the automobile industry are saying that by using a normal charger, you can charge for 8 hours. It will be for full charge, it will take 8 hours.
Yes.
But for using a fast charge, 80% of the charges can be full in 15 minutes.
Yes.
But why they are not announcing the full 100% charge? How much time it takes using fast charging?
One thing from my experience is that when you are going to charge an electric vehicle, there will be some battery left in your, some charge left in your battery. Okay. So we never need to charge 100%. Okay. Let me take a real life example. When your phone is turned down to 0%, is it actually 0%?
Then it will be there.
Yeah, exactly. And also, when your phone is charged for 100%, is it actually 100%? No, there is always a gap, margin of safety. Okay. So only every charging station will only provide 80 to 85% charging. Okay, they will never provide 100% charging because it will overcharge and may destroy the battery. Okay.
Okay.
Do you use AC supply or DC supply for fast charging?
DC is common, but AC is the best option. Okay, ma'am. DC is currently common in many countries, but AC is the best option. It will be the best provider for fast charging.
Okay.
If anybody have any more doubts, you can just type in chat box also. He will be answering you.
So there are already some questions in the chat box. Can you please answer?
Yes, ma'am. Something very, very ionic discussion has been typed in the chat box. That is about the passive pollution. Okay, you may have noted that there is a chat comment by Mr. Midun PS in the chat. The fact is true. The thing that Mr. Midun said is true. There is a factor of passive pollution. Okay, in a country like India, we are generating electricity by using what? Maybe thermal power plants. Okay, but in India only. Okay, basically I said about burning coal or burning petrol or diesel power plants. But in India, we are using hydroelectric power stations. Okay, I said the example of Sweden, right? The fact about Sweden is that they are getting their incentives and a large number of their country GDP from the exporting of coal. Okay, the dark fact behind some countries, some developed countries, is that they are gaining by suppressing other poor countries. Okay, there are two sides for a coin, and there are always some disadvantages for EV, but it has been overcome. And in countries like India, we are using hydroelectric power stations, and if we are further using solar power stations and renewable energy sources like wind energy, it will be the best problem solution. Okay, EV will be the only solution. I hope it is clear for Mr. Midun and others.
Sir.
Yes.
Can you explain PPT and production?
Yeah. Yes.
Sir.
Yes, we will be sent. Yes, sir, we will be forwarding you.
Okay, thank you, sir.
So, is there any more doubts? If it is not there, we can just move to the concluding session. So, I invite Ms. Nufa Said, Assistant Professor, Department of Triple to deliver the vote of thanks. Over to you, ma'am.
Good afternoon, all. Is it audible?
Yes, ma'am. Yes.
First of all, on behalf of Vedavyasa Institute of Technology, I extend my sincere thanks to the speaker of the day, Mr. Ahammed bin Zacharia, CADD Center Calicut, for sharing us the most valuable information on the very relevant topic of current scenario, which is electric vehicle. Next, I would like to thank our beloved principal, Dr. Sankita ma'am, for providing all the support for the webinar. Thank you, ma'am. Finally, I would like to thank all the active participants for making the webinar successful. Thank you all. Thank you once again.
Okay. Participants will be sending you the feedback forms. So once you fill the forms, you will be receiving your e-certificate also. Okay. Thank you. Let us wind up. Thanks to all participants.